Welcome to our first calculus unit. Now, before we get into some of the calculus problems, I'd like to take a few minutes and talk about what calculus is and maybe why and how we need calculus. So what is calculus? Calculus is the math of change. It talks about growing or shrinking or moving, all stuff about changing. Calculus is also the math of velocities, accelerations, tangent lines, slopes, areas, volumes. So we know lots of information already in our math education so far, from algebra to trigonometry to lots of ideas in pre-calculus. For example, we all know how to find the slope of a line, right? A slope of a secant line. As long as we have 2 points, we can use our slope formula, our y2 minus y1 over x2 minus x1, to find the slope, right? But what happens if I asked you to find a slope, but I only give you 1 point, a slope of a tangent line? If your line only touches at 1 point, how can we still find the equation of that line, including its slope? Another idea that you might be familiar with is area of geometric shapes. Now, regular geometric shapes, triangles, squares, rectangles. But what if I asked you to find me the area underneath a curved shape? Now, that's not so regular, and what we end up needing to use is calculus and the idea that we're going to talk about first, called limits. Now, I'd like to show you a quick chart kind of comparing the information we know already without calculus and maybe how we can advance our knowledge by using calculus. So here are a few common ideas that we're going to use in transition as we learn calc. One of them, a popular one, is finding the slope of a line, right? We just talked about how if I give you 2 points, you can find me the slope of that line. Using calculus, though, we're going to end up finding the slope of a curve. So maybe if it touches at 1 point, or how the slope changes as you're going along that curve. Similarly, we talked about the slope of a secant line versus the slope of a tangent line. Another one you might have done in your pre-calculus classes is maybe an average rate of change from a certain time to another time, right? Really what you're doing is finding the slope, right? The average rate of change. But in calculus, we're going to talk now about finding the instantaneous rate of change. How fast is something moving at one exact moment in time, not over a period of time. Some of the other ones we kind of discussed earlier is the area of regular geometric shapes, like the area of a rectangle, versus we needing calculus in order to be able to find the area underneath a curve or a curved shape. Same idea when we have three-dimensional shapes. We might be able to use a formula that we've learned in the past to find surface area of a cylinder. But what if it was more of a vase and your cylinder wasn't so regular anymore? There was lots of curves in it. Could you find the surface area of your vase? Well, we can use calculus to find the surface area of a certain solid that's not so regular. We can also use calculus to transform volumes of different shapes. Instead of doing volume of a regular solid, can we do volume of a region underneath a curve? So those are some of the kind of common ideas that we're going to transition from using our pre-calculus knowledge into using calculus to give us even a deeper understanding and more skills to be able to find all these new ideas.